And now we begin Chapter 7 on rational expressions. So in this first section of Chapter 7, I'm going to explain what a rational expression is, what we mean by the domain of a rational expression or rational function and how to find that out, and how to simplify rational expressions and reduce them to lowest terms. So when you hear the word rational in a math class, it usually means ratio null, having to do with ratios. That is, where you've got something over something else, like a fraction. So a rational number is a number that can be written in the form of a ratio or a fraction, like 2/3 or 9/10, or even 2/2, which would just be 1, but it still counts as a rational number. A rational expression is an expression, like maybe involving a variable, that can be written in the form of a fraction. So here are some examples of rational expressions. X plus 3 over 2x minus 8, or x plus 1 over x squared minus 6x plus 8, or negative 2 over y plus 13. So the numerator and the denominator of these expressions, well, they could just be a number, a constant, or they could involve a variable. They could even involve more than one variable, but that gets more complicated than most of the things we'll deal with. But they can be some sort of polynomials. So one thing you can do with a rational expression is, if it's got a variable in it, you can substitute in an actual number in place of that variable. You can evaluate that expression for different values of the variable. So for example, the expression x plus 3 over 2x minus 8 means to take some number plus 3 and then divide that by what you get when you take 2 times that same number minus 8. So we could ask, what's the value of that expression when x is 5? What do we get when we put 5 in place of x and calculate or simplify? Well, let's try that and find out. 5 plus 3 on top would be 8. 2 times 5 minus 8 on the bottom, that's 10 minus 8, so that's 2. So we've got 8 over 2, but that really just means 8 divided by 2, and so that would be 4. Now, if you are doing this on a calculator, be careful. If you put this all into a calculator, you're going to want to put parentheses around the numerator and around the denominator, like this. So we would put this in as parenthesis 5 plus 3, close parentheses, divided by parenthesis 2 times 5 minus 8, close parentheses. And yeah, the calculator tells me that's 4. If I left out the parentheses, 5 plus 3 divided by 2 times 5 minus 8, that's not going to come out correct because the calculator is going to do the division before the addition or subtraction, which is not what we need. We need the result of x plus 3 divided by the result of 2x minus 8. Okay, let's try another one. That same expression, but this time when x is negative 1. Negative 1 plus 3 over 2 times negative 1 minus 8. The negative 1 plus 3 on top is 2. And then I had to go back and correct my mistake here, but a 2 divided by a negative 10, first of all, a positive divided by a negative comes out negative, so the answer is a negative number. And then 2 over 10, you could either write it in fractional form as 1/5 or in decimal form as 0.2. And it should be negative 0.2. Okay, what's the value of this same expression when x is negative 3? If we put negative 3 in for x, on top we get negative 3 plus 3, which is 0. On the bottom, we get 2 times negative 3, which is negative 6, minus 8 is negative 14. And then 0 divided by negative 14 is 0. Because remember, 0 divided by anything else is 0. And what's the value of this expression when we put in 4 for x? What's the value of x plus 3 over 2x minus 8 when x equals 4? Well, let's try it and see. 4 plus 3 on top gives us 7. 2 times 4 minus 8 on the bottom gives us, 0. And then 7 divided by 0 is undefined. You can't divide by 0. If I ask my calculator what's 7 divided by 0, it's going to give me some sort of an error message. So this expression is undefined when x is 4. You can't put in 4 for x and get an actual number as the result. So that can happen sometimes with these rational expressions. Sometimes there's a particular number that if you try to put it in for x, it doesn't work. It's undefined. So we can talk about the domain of an expression, and that's everything that we can plug in. So if we can plug in anything we want to, then the domain would just be all the real numbers. But sometimes there's 1 or 2 numbers that if we try plugging them in, we get a division by 0 error, then those numbers would not be part of the domain. So in this example, the domain of that expression we were working with is all real numbers except 4. And in general, as a general rule, for any rational function or rational expression, the domain is going to be all real numbers except anything that would make the denominator equal to 0. So to find the domain of a rational expression, if I give you a rational expression and say, find the domain, or what's the domain of this expression, here's how you figure that out. Set the denominator equal to 0 and solve that equation. And then what you report for the domain, you say, okay, it's all real numbers except whatever you got as the solution or solutions to that equation. So let's look at some examples. We're going to find the domain of each rational expression. So here the expression is x minus 4 over 5x. And for the domain, we don't care what's on top. We just care about the bottom and when could it equal 0. So if I take that denominator 5x and set it equal to 0, I can divide both sides by 5 and get x equals 0. That's the solution to that little equation there. So that means the domain is everything except that number. All real numbers except 0. Now you can actually write it out in words like that. You can tell me, oh, the domain is all real numbers except 0. You can write it like this, x not equal to 0. And I think the way the book does it gets a little more fancy, uses set notation and says it's the set of all x such that x is a real number and x is not equal to 0. You can use any of those ways of telling me what the domain is as long as I can tell what you're saying. So as long as you tell me somehow that the domain is everything except 0, we're good. So how about negative 2 over y plus 13? Take the denominator, set it equal to 0, and solve. If I subtract 13 on both sides, I get y equals negative 13. So that means that the domain here would be all real numbers except, sorry, let me fix that. That should say a negative 13. The domain is all real numbers except negative 13. Or we could just say y not equal to negative 13. Because if we want this expression to work, if we want it to actually give us a number when we plug in a number, the number we can plug in has to be not equal to negative 13. So what we put in here for y can be anything other than 13. It can be 0, it can be 1, it can be 900, it can be negative 12. It just cannot be negative 13 because then we would get a division by 0 error. What about t over t squared minus 25? To find the domain, we take that denominator and set it equal to 0. T squared minus 25 equals 0. And this is a quadratic equation. The variable is squared. So I'm going to solve this by factoring. This is a difference of two squares, t squared minus 5 squared. So I can factor it into t plus 5 times t minus 5. Now each factor gets its own equation. T plus 5 equals 0 or t minus 5 equals 0. And then we get t equals negative 5 or t equals 5. So those are the bad numbers for this rational expression. Those are the things we need to stay away from so that we don't get that dreaded division by 0 error. So the domain is everything else. The good numbers are everything except these two troublemakers. All real numbers except negative 5 and 5. How about this one? What's the domain of x plus 1 over x squared minus 6x plus 8? So how do we do that? We take the denominator and set it equal to 0 and then solve that equation. It's another one of those quadratic equations. Let's see if we can factor this. If you want to pause the video and try to figure it out for yourself, you can. I got x minus 2 times x minus 4, because if you FOIL that out, you get x squared minus 4x minus 2x, so combined that's your minus 6x, plus 8. Separated into two equations, x minus 2 equals 0, or x minus 4 equals 0, and when we solve those, we get x equals 2 or x equals 4. So those are the troublemakers. Those are the x's we need to stay away from because they would give us a 0 in the denominator, which we do not want. So the domain, that's what we do want, that's what's okay, that won't get us into trouble. The domain is all real numbers except 2 and 4. Okay, I'm going to end this video here and come back in the next video. And the other thing we need to talk about in this section is taking one of these fractional or rational expressions and reducing it to lowest terms, simplifying it. We'll talk about how to do that in the next video.